Hello everyone. So today we are talking about another interesting problem. The problem name is merge two sorted list. Okay. So here in this case we'll be having two sorted linked list and we need to merge them. Let us read the description for more information. So you are given a head of two sorted linked list L1 over list 1 and list 2. Okay. Merge two sorted list two list in one sorted list. Okay. Out of two sorted list we need to make one sorted list. The list should be made by splicing together the nodes of the other two list. Okay, so we'll need to use the other two list sorted linked list and make the one sorted list. Okay, and return the head of the merged linked list. Okay, so here's an example pictorial representation 1 2 4, then we have 1 3 4. So we are taking 1 from here, 1 from here, 2 from here, 3 from this second one, 4 from here, 4 from here. Okay, so that's how it is forming. So here is another example. Here list 1 is this, list 2 is this, list will be this one. Okay, so we just need to return the head of this merged linked list. Okay, then we have given empty. So in the empty we'll need empty. If we are given something like this, we have some values with 0, so we need to return only the 0th one. Okay, the constraints, this is an important thing. So the number of nodes in both a list is in the range from 0 to 50. Okay, and values can be from -100 to the 100. Both list 1 and list 2 are sorted in non-decreasing order. Okay, non-decreasing means it will be having values like 1 2 3 4 like this. Okay, it will be increasing and it can be something like 1 2 2. Okay, which is nothing but the non-decreasing fashion. Okay, it will be increasing fashion. So this is they have given. Now let us see the first solution. The solution is the iterative solution. The time complexity for this solution will be order of n, and the space complexity will be again order of n. Okay, because we'll be storing the size for them. Okay, we'll be creating a new linked list whose size will be size of order of n. Suppose the size will be n for this, the size will be m for this, and the size will be n plus m. Okay, for the new merged linked list. Okay, so that is what we are going to be creating. Okay, so in order to solve this question. Okay, so that's a simple thing. The space complexity, time complexity will be order of n, space complexity will again be order of n. It will be nothing but m plus n, the size of both of them. Okay, now what we going to be doing, it's very simple. If you have already solved some merge sort questions, then it is very simple for you. So first condition will be whenever we are finding that list 1, if list 1 is empty, then we simply need to return list 2. Okay, the condition can be something like this: list 1 is empty, list 2 has some values like 1 2 4. So in this case we just need to return this list 2. And it can happen that list 1 is empty, list 2 is having it can happen like list 2 is empty and list 1 is having some values. In that case we need to return list 1. Okay, so that's the basic checks that we need to be using. After this checks, what we're going to, if we have some values, then we'll be starting our pointer here. Okay, both of these conditions will be checked. Now one by one we'll be putting onto a current, okay, or we can say output linked list, anything we can call that. Okay, OPT. So in that, what we are going to be doing, we'll be taking one by one. So if it is less than, if this value, we'll be comparing basically. If it is less than that, okay, any value which is less than, we'll be pushing into this, and we'll be again putting in updating our list to the next pointer. So in this case, you can see we have list 1. Okay, so we have one value. If both of them are equal, so first we'll be putting this value here. Now once we have done that, we'll be updating this our list 1 pointer here. So list 1 will be pointing here. Okay, now this one value is already been pushed into this. Okay, the condition was something list 1 value, which is this one, is less than equals to this value. Okay, if it is that condition, then we'll be pushing this one here. Now once we are done that, we'll be updating over this one list. Okay, pointer here, the pointer will be pointing to years. Okay, and in this case we'll be checking this both values 2 and 1, which of them are smaller. So 1 is smaller, so 1 will be updated here. Now again this value will be pointing here. Now again this 2 and 3 are compared. Now which one is smaller? 2 is smaller, so 2 will be pushed into this. Now again this will be updated to 4. Now again this 4 and 3 will be compared. Which is them smaller? 3 is smaller, then 3 will be pushed. Now again 4 and 4 will be compared. Okay, so 4 and 4 is less than equals to 4. That's the condition that we are going to be using. So 4 is pushed here. 4 is it has been out of this. Okay, so you can see list 1 becomes empty, it is pointing to the null. So we just need to append the whatever the element are there afterwards this one. So we'll be just appending 4 in this case. Okay, so that's a simple idea. It is fairly easy to understand by the code example. So let us see the code for this. Okay, so here is the iterative solution. So let us see what we are doing here. So first thing is what I have told, that list 1, if it is pointing to the null, okay, which means list 1 is empty. So in that case we are just returning list 2. If list 2 is empty, okay, then list 1 is returned. Okay, so that's the base condition checks. Okay, that is done. Now again we are creating a list, okay, a list node. Okay, in list node what we are doing, we are calling that as head. Okay, we are again creating a current node which is pointing to the head. Okay, so that's the temporary list node which we have created. Okay, and now that current is pointing to the head. Okay, this current will be basically used to put the values one by one into the head list node. Okay, and this head list node is being returned from here. This is basically head dot next is returned from this position. Now this while loop, let us see first, before going into this while loop, let us see what is this return. So if current dot next is equals to list, okay, so whatever the current, what is current at next, it depend upon this ternary condition, that if our list 1 is not equals to null, which means we are going to be returning list 1. If it is not that, then it will we will be putting our list 2. Okay, so that is we already discussed. Now let us open this list while loop and see one by one. So for this is already we discussed, like list 1, the condition is like list 1 is not equals to null and list 2 is not equals to, both should not be null. Okay, so here the first condition, that list 1 value should be less than equals to list 2 value. So current dot next will be list 1. Okay, and then simply updating our list to the list dot next. In else condition, which means it is small, it is greater, this list 1 is greater, so in that case we'll be putting current dot next equals to list 2. Okay, which means that list 2 is smaller. Okay, and then list 2 will be updating our list 2 dot next. Okay, then current we are updating each time. So current equals to current dot next, that is we are going to be updating every time. So this is what we are done, that current dot next, it is something that the output is this one, and if list 2 is not equals to null, okay, list 2 is not equals to null, list 1 will be putting into that, and list 2 else will be putting list 2. So these are the remaining ones. Okay, if one gets emptied, so second will be pushed into the current dot next. Okay, as simple as that, and then we'll be returning head dot next. Okay, so this is just the iterative solution. The time complexity order of 1 because there is only one traversal. Okay, in both of the list node, and space complexity order of whatever the size will be there for both of them. Okay, addition of both of them, order of n plus m. So let us now see the recursive solution for this. Okay, so let us jump to that solution. Now let us see the time complexity. Okay, so the previous question which we saw, a previous approach, that was the iterative approach which we saw, the time complexity was order of m, maximum of n comma m. Okay, where m is the size for the first linked list. Okay, and n is the size for the second linked list. Okay, and what with the space complexity, that is the order of m plus n. Okay, so in this solution also the time complexity remains the same. Okay, order of m plus n will be the time complexity, and the space complexity will be order of m plus n, because we are using call stack here. Okay, so that will be remaining same, but just to see the iterative approach, we are just discussing this solution. Okay, so the base condition remains same, that if list1 is equals to null or list2 equals to null. In both of the cases, we will be checking this condition that if list1 is null, we will be returning list2, otherwise we will be returning list2. Okay, if list1 is null, if list1 is not equals to null, then we will be returning list1, otherwise list2. Okay, and then we have this one, that if list1, this is the same condition that we saw in iterative solution as well, that list1 dot value less than equals to list2 dot value. So in that case, list1's next will be calling this function recursively, okay, in which we are calling this function with the list1 dot next as the first parameter. Okay, then we have list2. Okay, so this is how we are going to be doing. Then again, if it is not that condition, that list2 will be updated. List2 dot next will be merge to linked list, merge to list function, and then list1 and list2 will be called here. Okay, so that's going to be simply returning, and these are the base condition. Okay, that is going to be returning the solution to this problem. Okay, so that's the recursive solution. So I hope the solution was not too much confusing. So iterative solution was pretty simple, and you can go with that as well. Okay, and if you want to go with this recursive solution, you can make the diagrammatic representation and try to understand this more in depth. Okay, so that's it for this video. We'll be meeting with the next interesting video. Thank you for watching, guys.